Okay, so here in this video we're going to learn how to do integration by u substitution. So far we have going for us when we have x to the nth power, like x to the second dx, we can just increase the power by 1 and divide by the new power to get the antiderivative, and of course adding plus c for the most general antiderivative. So now we're going to move into what is called integration by u substitution. So let's start with an example of, suppose we have the indefinite integral of 2x minus 3 to the 5th power dx. The only option we have right now before we get to u substitution is to expand this and multiply it by itself 5 times. That would not be very efficient. So what we can use is u substitution, and we choose u to be the inside stuff. So we're going to choose u to be 2x minus 3. I'll take the derivative of both sides with respect to x. So it'll be du equals 2. The derivative of this over here is 2 dx. And now I have to build this integrand up so I could put in a du. So I'm going to put in a 2, but because I put in a 2, to be fair, I have to take out its reciprocal, 1/2. So that these would multiply to give you 1. So that's fair game. Now the 2 dx would become my du. So this would become 1/2 in front. This and this become my du. So that's gone. That's from this part. And this becomes my u to the 5th. So then now I have it of the form u to the nth power, and that antiderivative would be 1/2 times u to the 6th over 6 plus c. And just multiply the fractions out, we'd get 1/12 times 2x minus 3 to the 6th power plus c. Alright, another example. Suppose we have the indefinite integral of x squared dx over 1 minus 3x cubed to the 2/3 power. Alright, so again, where do we start? We have to choose a u. So our u would be the inside stuff. The inside stuff of the quantity. So I'll choose u to be 1 minus 3x cubed. Take the derivative of both sides with respect to x. So du would be equal to negative 9x squared dx. So now I have to build the integrand up to look like this. So I'll put in a negative 9, take out a negative 1/9. And this will roll into negative 1/9, the indefinite integral of du over u to the 2/3, because this is my u now. But that's still not of desirable form. It's still not of u to the nth. So it will become that when I rewrite that as the indefinite integral of u to the negative 2/3 times du with the negative 1/9 in front. Now I'll increase the power by 1, adding 3 over 3. And I'd get that to be u to the 1/3. To divide by a fraction means to multiply by its reciprocal, which would be then 3. So it would be 3 times negative 1/9 plus c. And you know this would reduce to negative 1/3. So it would be negative 1/3 parentheses 1 minus 3x cubed, close it, to the 1/3 power plus c. And of course we can check any antiderivative by taking its derivative and see that we get the function back in the integrand. Alright, next, another example is, suppose we have the indefinite integral of x dx over the square root of x squared plus 9. So once again, choose u. Try picking u to be the inside stuff of the quantity. So u would be equal to x squared plus 9. Du would be equal to 2x dx. Now look to build the integrand up of this form. So I want to build the integrand up to match this. I can never put in a variable. I can put in a constant and take out its reciprocal, and that's fair. But I cannot put in a variable. So when I take this derivative of u, the variable portion has to be in the integrand. If it's not, then I did not choose a good u right now. So now I'll put in a 2, take it as reciprocal 1/2. This becomes 1/2. This is all now my du. This is what I wanted. And then now this would become the square root of u in the bottom. It is not of u to the nth, so I have to make it that way. And rewrite it as 1/2 the indefinite integral of u to the negative 1/2 du. Increase the power by 1, so it would be then u to the 1/2 multiplied by its reciprocal, which is 2, plus c. These would divide out. And of course, u is x squared plus 9 to the 1/2 plus c. So there's the most general antiderivative. Next, one more example. Suppose we have the indefinite integral of 2x plus 1 times x squared plus x, close it, to the third power dx. So which one would I choose as my u? Try the one with the power other than 1. So try the one with the highest power. So try u to be x squared plus x. Its derivative, take the derivative of both sides with respect to x. Du would be equal to 2x plus 1 dx. Do not forget to put the dx. And this is times all that. Well, I've got a match. I'm good. This here appears in the integrand exactly as it is. So this would become then u to the third du. And that would just become u to the fourth over 4 plus c. And u is x squared plus x to the fourth over 4 plus c. Okay? And obviously this is a real easy derivative to check. I could take the power, drop it down, decrease this by 1, times it by the derivative of the inside, which is right there, 2x plus 1. And notice that this now is in the integrand, which means this antiderivative is correct. Okay? And just one more. Suppose I would have, let's see here, indefinite integral of 1 minus 1 over x to the third over x to the second dx. So again, think about choosing u to be the inside stuff of the quantity. So u would be equal to 1 minus 1 over x. The derivative would be, the derivative of 1 is 0. This here, no need for a quotient rule. Just rewrite it as negative x to the negative first. So then drop the power down, be positive x, decrease it by 1, x to the negative second. So remember, you're taking a derivative here, where you drop the power down and decrease the power by 1. So that derivative would be then positive 1 over x squared dx. And notice I have this appear in the integrand exactly as it is. So this would all become then, this is my u, so it would be u to the third du. The antiderivative is u to the fourth over 4 plus c. And this would be 1 minus 1 over x to the fourth over 4 plus c to be my general antiderivative. So there are some examples in doing integration by u substitution.